Good morning, dear students. How are you today? I hope you're fine. Today we are going to talk about histograms. What's histogram? It's very easy. Let's do it. It's kind of data representation. A histogram shows the distribution of numerical data. Here I'm going to distribute my numerical data. Okay, the numerical data. We have two kinds of data. Do you remember? The categorical data and the numerical data, as I told you the last session. So we are going to distribute the numerical data using intervals on a number line. The height of each bar represents the number of data values. Okay, values of the number of data values in that interval. An interval frequency table, interval frequency table is a frequency table in which the number of times a data value occurs, okay, is shown within a range of values instead of a single value. Use the grocery shopping survey data to complete example 1.3. So I have here a group of students wanted to know how long customers spent shopping at a grocery store. The data shows the number of minutes each customer spent in the store. So I have here the data. Okay. Here, example 1. Use an interval frequency table to organize the data here. The frequency is the number of times each data value occurred. Use tally marks. Do you remember tally marks? Okay. To keep track of each occurrence of a value. Okay, I have here step 1, how to create the histogram. Step 1, draw a horizontal line, mark the intervals to match the intervals. Okay, so in the interval frequency table, label the axis to show the unit of measurement. So here, step 2, here draw a vertical number line, label each frequency. This line represents the frequency of the values for each interval. Give the graph a title. The axis for the frequency scale starts at 0. The highest frequency value should be greater than the greatest value in the interval frequency table. Okay, here, as if here. Can you see it here? Yeah. We draw the horizontal number line and the vertical number line, and here start from the 0 as he mentioned, and here what the axis for the frequency scale starts at 0. The highest frequency value should be greater than the frequency you have given in the question. Okay, it must be greater than the value of the interval table. Okay, now step 3, draw a bar for each interval. Draw a bar for each interval. The height of the bar is equal to the frequency value for the interval. So I want here to show you the example and how can we solve it. It's very easy. From 10 to 19, I have 5. From 10 to 19, I have 5. So here until I get up, yes, to 5 here. 20 to 29, I have here 20 to 29, 5 and 2 7, so 7. From here 20 to 29, so I have here between 6 and 8, yes, 7. Then from 30 to 39, from 30 to 39, here I have from 30 to 39, yes, I have here how many? 12. So I'll go up until I reach 12. Here I have from 40 to 49, from 40 to 49, here I have 6, here I have 6. So I will draw until I get to 6. It's very easy. Here I have something different. How does the number of intervals used to affect how does the number of intervals used affect the shape of the histogram? You choose which interval to use in histogram. Okay, here I added some intervals. Alternate interval frequency table using the same data set for example 1, from 15 to 19, and then from 20 to 24, from 25 to 29, from 30 to 34, from 35 to 39, okay, from 40 to 44, from 45 to 49. So here I have added other intervals, okay? I have added other intervals. So from 15 to 19, it gave me the same 5. From 20 to 24, just 1. 25 to 29, 6. 30 to 34, 10, and so on. Then, do you notice that here the shape of the intervals differs, right? It differs here. From 15 to 19, 5. 15 to 19, I draw here 5. From 20 to 24, 1. 20 to 24, just 1. And then 25 to 30, 25 to 30, 25 to 29, here 6. 25 to 29, I didn't reach here the 30 yet, so I put here 4, 6. Then 30 to 34, 10. 30 to 34, 10. Then 40 to 44, yes, I have here 3. Okay, then I have 40 to 44, 3, I told you this. 45 to 49, 3. 45 to 45 to 49, here 3. So a greater number of intervals changes the histogram shape. The data appears to be more spread out and less symmetrical. Can you see? Yeah, than the histogram in example 1. Okay, moving to the other slide. Okay, in the same example here, a fewer number here, if I have alternate frequency table and histogram 2, if you here if you have taken here some of the intervals by making the interval space here wider from 15 to 39 and from 40 to 64, look with me here, a fewer number of intervals changes the histogram shape. The data distribution appears to be skewed to the right. They skewed to the right. Okay, can you see the differences between the three? The differences between the three histograms now? This is skewed to the right, okay, and this is appears that it's less symmetrical. Okay. Here in example 3, interpret the shape of a histogram. Look at the histogram from example 1. Here I have the time spent, frequency, and the time in minutes. So this shape of histogram is approximately symmetric. Most of the customers spent between 30 to 39 in this area shopping, as shown by the peak of the graph, the peak in the graph. Okay, the center of this histogram is around 30 to 39 minutes. The center tells you the typical amount of time customers spent shopping in the grocery store. Example 4. Compare a histogram and a dot plot. A histogram only shows the total number of values in an interval. A histogram is a good choice to use the large data sets with many unique data values. A dot plot shows each individual value. A dot plot is a good choice to use a small data sets. Here, number of miles walked in a 1 week. If the data values change, the shape of the histogram might change. Here, can you see this? Here, how data changes, possible changes to shape of histogram. More smaller values means more customers. More smaller values means more customers spend a shorter amount of time grocery shopping. Here, possibly changed to a shape of histogram, the histogram is skewed right. Okay, here more greater values means more customers spend a longer amount of time grocery shopping. Here the histogram, if it changed, it will be skewed left. Okay, create an interval frequency table and histogram, and then interpret the histogram for each data set. Let's do it together step by step. Okay, step by step. Test scores on a math test out of 100. 98, 94, 80, and so on. The first step, what to do? Order the data values least to greatest. From least to greatest. 76, 77, 80, 81, and so on until I get to 94. And if I have repeated number, just write it. Okay? Okay. Choose frequency intervals. The lowest score I have here, 76. I'm now choosing the frequency intervals. So I write the lowest score is 76. The highest score is 98. Okay? Okay. Here, score intervals frequency. I have here from, I will write from 76 or take the number before 76. Of course, take the number before 76. So I write 75. 75 until 79. 75 until 79. Focus with me. Yes, it's repeated how many? 2. 76 and 77. Yes, of course. Okay. The two numbers here in between 75 and 79. Here from 80 to 84. From 80 to 84. Here between 80 and 84, how many numbers? Yes, let's search 80 to 84. So I'm taking with me what? Let's count together. 1, 2, 3, 4, 5, 6, and 7. So I will write here 7. From 85 to 89, step by step, focus with me. From 85 to 89. From 85 to 89. Yeah, let's do it. 1, 2, yes, 2, just to go to 90. No, don't go to 90. From 90 to 94. From 90 to 94, let's count together. 1, 2, 3, 4, and 5. So I'll write here 5. From 95 to 99. From 95 to 99, I just have 2 here and I write 2. Okay, until this step, it's okay with you? I think so. Create the histogram from the interval frequency table. Interpret the histogram. Okay. How can I draw it? I just draw here the histogram by drawing the bars here. Okay, they are beside each others. Here it's called the histogram. It's different from the bar line. The bar line, there is a space between them. Okay, but here in the histogram, they are beside each other. Okay, from 75 to 79. From 75 to 79, draw a bar and goes up until 2. From 80 to 84. From 80 to 84. I'm drawing here from 80 to 85, I know. But when I'm calculating, I'm calculating or counting until 84. So here I go up until 7. Here 7 between 6 and 8. Don't forget. And then from 90 to 94, 5. 90 to 94, 5 between 4 and 6. Then from 95 to 99, I have here 2 until 2. So interpret the histogram. The most students here between, this is how to interpret, to represent the data given here. The most students scored between 80 and 84. Between 80 and 84, as you see here. Okay? Percent on the test. Okay, moving to another example here. Gas mileage, miles per gallon of different vehicles, 28, 28, and so on. The first step, order the data values from least to greatest. As I told you, choose frequency intervals. This is the second step. The lowest miles per gallon is 16. Here is 16, and the highest miles per gallon is 32. So from 16 to 18 I have here, from 16 to 18 I have here just 2. From 19 to 21 I have here 19 to 21 I don't have any, 0, and so on. The same idea. Create the histogram from the interval frequency table. Interpret the histogram. The number of different vehicles is, the number of different vehicles is what? Is 18. The number of different vehicles is 8. The total here is 18. The gas mileage for most vehicles was between 28 and 30. 28, where 28 and 30, this is the peak. As I told you before, the distribution has more higher values for miles per gallon. This means the distribution is what? Scaled left. Scaled left. Okay, this means that the distribution scaled left. By that we have covered the lesson. Moving to the other lesson, keep with me. Moving to lesson 4, measures of center mean. Today also we are going to learn the mean, how to measure the mean. So the measure of center of data set summarizes all the values with a single number in this lesson. You will learn about one of the measures of center, the mean. The mean is the sum of all data values divided by the number of data values. So the mean is what? The sum of all data values divided by the number of data values. It's very easy. Let's see. Example 1 here. The dot plot here shows the number of hours students spent studying for a history test over a period of 1 week. The dot plot is close to what do you think? Is close to symmetrical. The mean is a good measure of center for this data set, because the data distribution is not skewed and there are no extreme data values here. So find the mean of the data shown in the dot plot. The dot plot represents the data set. I have here 2, 4, 4, 5, 5, 5, 5, 6, 6, 6, 7, and 8. So as I told you, we have here a rule I should follow. Here mean equal the sum of all data values in the data set over number of data values in the data set. So I have here 2 plus these numbers, the sum of the data values here, over what? Over how many are these? 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, 12. So here the sum of the values over what? Over the number of data values of the data set. So I have here the number will be, the mean here will be 5.25 hours. The 12 dots in the dot plot are the 12 data values in the data set. The mean is typically value. In this case, the mean represents the typical number of hours students studied for the history test. The typical number of hours was just over 5 hours, 5.25 hours, or 5 hours and 15 minutes. Do you know that scientists use the mean, median, and mode to describe many kinds of data? Statistics can show how well athletes perform. For example, a runner may track how long it takes him to run a distance. The mean will give his average speed and help decide how to get faster. Athletes also track their personal best scores. The table shows Usain Bolt's record-breaking times running the 100 miles sprint. What do you notice about Bolt's time here? What do you think? Okay, here in 2008 Olympics, here 9.69, 2009 9.58, and in here the time in seconds. Okay, so here 2012 9.63, and here in 2016 9.81. Here he is 9.69, okay, but here he's getting better, then he get back again, then he is getting back and back because he's getting old, I think so. Data were collected, example 2, data were collected from 2 groups of students. The data shows the number of points each student earned on his or her semester project. Find the mean and spread for each data set. So data set 1, data set 2, I have here numbers and I have here the data collected. Mean for data set 1, I will do what the rule, I will add all here the values, okay, the sum of the values over the number of values, okay, it will give me here 81. And mean of data set 2, I have here all the values, I will divide it by the number of values here, which are also 10, and give me also 81. Does the mean represent a typical value in both distributions? Each data has the same mean of 81 points. The mean is the second data set, should be more accurate measure of center than the mean in the first data set. Why? Study the shape of the data distribution here to know for sure if the distribution is close to symmetrical. The mean is a good measure of center for the data set here. So if it is skewed, the mean is not the best measure of center, okay. Here the mean of a data set that is close to symmetrical is more likely to represent a typical data values. Example 3, create a dot plot to help justify the conclusion about the data sets in example 2. So here I have here the dot plot from 60 to 90. Can you see from 60 to 90 here? Because this is the interval that I have. Okay, 60 is repeated 2 times as you see, and 84 is repeated 3 times, and 86 now is repeated 2 times, and 90 is repeated just 1 time. So this is the distribution of your data in set 1, and here the distribution of data in set 2. I have here 76 is repeated 1 time, 78 1 time, 81 2 3 4 and 5 times, 84 1 time, and 86 is 2 times. So this is the distribution of my data here. So conclusion, I know that you are experts now, my dear students. So data set number 2 has a data distribution that's close to symmetrical. This is close to symmetrical, right? The data distribution for data set 1 is asymmetrical. This is the opposite of symmetrical. The mean of 81 is a better measure of center for data set 2. Okay, so then it's in data set 1 because it's symmetrical here, right? Okay. The average, do you know that the mean elevation in Oman is 310 meters. The lowest point is the Arabian Sea at 0 meters. The highest point is at Jabal Shams at 3004 meters. The average elevation in 4 different countries is 214 meters, 139 meters, 209 meters, and 175 meters. What's the mean elevation of these 4 countries as a group? Here I have the mean. I will add all the values over the number of here values, so it gives me 184.42 meters. It's very easy. Step by step, we have here find the mean of the data set and data shown in the dot plot. Data set here, I have here the values, then I will add all the values over the number of values 1 2 3 4 5 6 and 7 After this, I make what I plot my here. I make here dot plot by writing here 4, 5, 6, 7, and 8, and here I have how many times? Yes, here just one time, and here 3 times. This is other one, and here 1, 2, 3, 4, 5. Yes, again 1, 2, 3, 4, 5, and here 1, 2, 3, 4, and here just 2. So the mean here, I want to write it by myself. This is an example, and this is another. Okay, so I have here 4 just one time, 5 3 times, it appears 3 times, 6 it appears how many times? Here we said 5, then 7 1, 2, 3, 4 times, then 8 2 times. Then can I do it now by using the dot plot only? So I can do it. Yes, it's here 1, 2, 3. Yes, I will add all the numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, I write here the 15. Or can I can just here count all the numbers, count, not making sum, so it will give me 15. So 93 over 15 will give you 6.2. By that we have covered the mean lesson. Moving to the other lesson. Describe distributions using mean and mid. A measure of center describes a data set with a single value, and measure a variation describes and a measure of variation describes how data set values vary. The absolute deviation of a data value is the distance, here it's important, of that value from the mean. The mean absolute deviation, the mean absolute deviation, here MAD, is the average. This is the abbreviations for mean absolute deviation, is the average distance of the data values from the mean. So for example, here find the mean absolute deviation of the data set. I have here 4, 17, 11, 12, and 6. Step 1, find the mean of the data set, and I told you before the mean equals the values, the sum of the values, okay, by the number of the values. So here it will give you 10. Step 2, find the absolute deviation of the data set. Okay, how can we do it? I will tell you now. I write here the values for 17, 11, 12, and 6. Absolute deviation from the mean. I have here the mean 10, so I will take 10 minus the value. It's very easy. Okay, 17 minus 10, 11 minus 10, 12 minus. So what I'm doing here, the absolute deviation. Don't forget absolute means what? I have here 10 minus 4, okay? And I have here 10, and I have here 17, and what 10? So the bigger number minus the smaller number, without, which gives me the absolute here. 11 minus 10, 12 minus 10. Here I have 10 minus 6, okay, the greater number minus the smaller one. So here I have calculated the absolute deviation from the mean. So I have here step 3, find the mean absolute deviation. Okay, mean absolute deviation equals what? Equals the 6 plus 7 plus 1 plus 2 plus, yes, plus 4, it give, okay, all over 5. Let's, okay, explain this to you. So here 6 plus 7 plus 1, this is written wrong. 12 minus 10, it gives you 2. So here it's written right, 2. Then plus 4, all give me 20, and the number of them are 5. So 20 over 5 will give you 4. So the mean absolute deviation for the data set here is 4. Is it easy or hard? It's very easy. It's not difficult at all. Find the mean absolute deviation for the dot plot. Round your answer to the nearest 100 if necessary. Let's do it step by step. In the last lesson, you learned that a measure of center describes a data set with a single value. A measure of variation describes how data set values vary. In this lesson, you will use what you know about the mean to learn about a new measure of variation. The mean absolute deviation, or MAD. This is called mean absolute deviation. So here, the deviation from the mean for individual data values refers to the distance and the direction of data value from the mean. Deviation is the difference of a value from the mean. The deviation may be negative, as I told you in the example, when below the mean, or positive when above the mean. In chapter 12, you learned the absolute value, as I told you, of a number refers to the number's distance from zero, regardless of its direction from zero. The absolute deviation is the distance of data value from the mean of data set. It's the absolute value of deviation. So the mean absolute deviation, now it's very easy. MAD is the average distance of the data values from the mean. So example here again, find the mean absolute deviation of the data set 10, 25, 10, 35. So step 1, step by step, I like this. Here mean will be 10 plus 25 plus 15 plus 30 plus 5 all over 5, the number of them, so it will give you 17. This is the first step. Step 2, find the absolute deviation for each data value in the data set. Find the difference between each data value of the mean. This is very easy. It's easy now. I write here the values, okay, from 5, 10, 15, 25, 30. Then the mean, I know the mean here is 17 for all because I calculated it now. So distance from mean or absolute deviation from the mean, this is the same distance from mean or absolute deviation from the mean. So here's 17 minus 5, 17 minus 10, 17 minus 15, 25 minus 17 because it's the greater, okay? I know I want the absolute, yes, 30 minus 17, okay? Then I get the answers here. Find the mean of the distance found in step 2. It's very easy now to do it, okay? 7 plus 8 plus 2 plus 13 plus 12 all over 5. So all over 5, so the answer 42 over 5, 8.4. The mean absolute deviation for the data 8.4. I took here all the numbers and I added them over the number of them, 1, 2, 3, 4 and 5. I took 12, 7, 2, 8, 13 and all over 5, so it gives me 8.4. The absolute deviation is a distance. It cannot be negative. Find the difference between each data value and the mean. By this, we have covered the lesson. Study well from the YouTube presentations, from the PowerPoint presentations. If you have any questions, please don't hesitate to send them on Google Classroom. Miss Dina Math. Thank you.